Welcome to All This Math. This is Professor Parker, and today I'm honored to have a special guest with us today, Assata. Assata, stop being goofy. Come on, we doing math. This is not time to play. It's not time for playing. All right, we gotta be serious. Straight. Come on. Serious face. Stop making me laugh, man. Come on. All right. Look, this is serious business. We're doing division by the box method.
Okay.
We're doing division by the box method, right? This is not a laughing matter. All right. So I have my daughter, Assata, here to help us do division using the box method, okay? We also can do division using the traditional long division algorithm, and we also can do division by what is known as using partial quotients. But today in particular, we're going to use something called the box method. And truth be told, I recently just learned about the box method, and I thought it was kind of cool. This is a method that I never learned when I was in elementary school. You know, shout out to my teachers in elementary school that taught me the traditional long division method. But I want everybody else to, in addition to knowing the traditional long division method, which I'm going to do a different video on, and I've done some videos on in the past, but I'm going to do a different video on the traditional long division method. Also, I want you to know how to do the division by box method. All right, so Assata said I should use a blue marker, so I'm using a blue marker. So this is how we started, right? We look at number one. We have two examples, by the way, of course, right? So number one says 528 divided by 2. So the first number, Assata, is called the dividend, all right? It's called the dividend, all right? That's your first number, right? And then that's the number that's actually being divided, right? It's called the dividend. The second number, that's called your divisor. All right. Now, these are all mathematical terms that you're going to memorize over time. OK, so the first number in a division statement is called the dividend. The second number is the divisor. And the answer you get is called the quotient. All right. Dividend, divisor, quotient. All right. Let me write those down. Dividend,
Divisor.
First number. Second number is called what?
Divisor.
The divisor. And the answer is called a quotient. All right. Now, by the box method. Okay. So we draw a box. So for number one, we draw a box. Looks like this. And then we're going to divide this box up into columns. Now, how do you know how many columns you should have? You should have as many columns as you have digits in your dividend. This is 528. How many digits does 528 have? How many digits?
528.
528. How many digits is that? 5, 2, 8. How many digits is that?
3.
3. Exactly. So, because 528 has 3 digits, we draw 3 columns.
1, 2, 3.
Well, 2 lines make 1, 2, 3. All right. Now, then what we do is we draw a line, right? A horizontal line right here, and this is where we put the actual digits from the dividend. All right, so we put the 5 right here, put the 2 right here, and we put the 8 right there.
I did this in my school.
You did? You told me you never did this before.
With addition.
Oh, all right, with addition. Okay. All right. So now the divisor, where does the divisor go? The divisor is 2. The divisor goes outside of the box next to the row where the dividend is. All right. Now let me do something. Let me erase this 1 and put it further out. Yeah, I know. It'll be all right though. All right. Because I don't want you to confuse this 1 with this 2 and think it's 12 or something else like that. But anyway, now we start actually doing division. So you say to yourself, basically 5 divided by 2, or how many 2's can fit into 5? How many whole 2's can fit into 5? Right? I know 2 times 1 is 2, and I know 2 times 2 is 4, so that's closer to 5. And I know 2 times 3 is what? What's 2 times 3?
Oh, wait. 2 times 3 is 6.
2 times 3 is 6. Now that's too much, because 6 is more than 5, right? So we would say that 2 goes into 5 how many times? Twice, right? All right? So now you say 2 goes into 5 twice, so you write the 2 up here, and then the next step is to multiply. You multiply. So you multiply 2 times 2, and you get what? What's 2 times 2?
2 times
2 times 2 is 4. You're right. All day long. So then you put the 4 right here, and then you're going to do subtraction. So now, Assata, what is 5 minus 4?
1.
5 minus 4 is 1. So you write the 1 right there. Now, in the box method, that 1, which was your difference between 5 and 4, you draw an arrow up to the next column, and then you put that 1. And now that 2 turns into a 12. It's wild, right? It's wild, right? Yeah, right? So the 1 turns into a 12. Now, we repeat the same process. So now, how many times does 2 go into 12? Or 2 times what equals 12?
2 times 6.
Yes, 12 happens to be a multiple of 2. So 2 goes into 12 evenly, actually, right? So 2 goes into 12 6 times. So you take that 6 and you write it above this column. And then you multiply 2 times 6. Tell me again, what's 2 times 6?
12.
12. So then you write 12 underneath it there. And then you write the minus sign. And then you do an underline like that. Now, what's 12 minus 12, Assata?
0.
0. Boom, right? Now, just like in the first column, how we brought that 1 up to the next column, we're going to do the same thing with the 0. All right, so we do this, we put that up there. Now, you might be wondering, like, 0, 8, what's that? 0, 8 is the same thing as just 8, right? It's like putting a 0 in the tens place. If the 0 is in the tens place, then there's essentially no number in the tens place, right? So our number is just 8, okay? So now we repeat the process again. Assata, how many 2's can fit into 8? Or how many times does 2 divide into 8?
4.
4 times, because 2 times 4 is 8. All right? So then you put a 4 up here. And then you multiply, like we've been doing. We do 2 times 4, which is 8. And then we're going to subtract. And Assata, what's 8 minus 8?
0.
0. Now, this number right here, at the end, when there's no other columns left, and the number that you end up with after you do subtraction, this is our remainder. So we have a remainder of 0. So that means that our answer is 264, or our, what's this called? Quotient. Quotient. That's what that's called. So our quotient is 264. So that means that 528 divided by 2 is equal to 264. And there's no remainder. All right? So that's the box method. All right? That's the box method. Now, it might look a little crazy to you if you've never seen this method before. But I think I like it. I did a few problems. I practiced with it. And, I mean, what do you think about it? Well, you don't have no frame of reference for real because you never learned. I never taught you the long division method. So you don't have nothing to compare it to. Right? Yeah. So what am I asking you for? All right. So anyway, all right, let's try number 2. Read that for me.
1,927 divided by 6.
Okay. 1,927 divided by 6. So box method, we're going to draw a box. So number 2. We draw another box. And how many columns should I have in this box? If my dividend has
4 numbers.
4 numbers in it. So how many columns should I have?
4.
4. Because we have an equal number of columns to digits in the dividend. So I go boom, boom, boom. All right. And then I draw a line for my dividend. My quotient goes on top. All right. So I put the 1 right here. I put the 9 right there. Put the 2 right there. Put the 7 right there. And then, Assata, where does the divisor go? You remember? Where does the 6 go at? Where do I put the 6 at? Not on top. The quotient goes on top. Look where the 2 was in the last problem.
On the side.
So the 6 is going to go on the side. We're going to put that right there. All right? All right. Now, we do the same exact steps. Okay? Now we say, okay, well, how many 6's can fit into 1? How many 6's? Sounds weird, right?
Yes.
Because 6 can't go into 1. 6 is too large. an entire 6 can't go into 1. A fraction of 6 or a decimal portion of 6 can go into 1, but not an entire 6. So that would mean that 0 6s can fit into 1. So we put a 0 up there. Then we multiply. We did our division, now we multiply. What's 6 times 0?
6 times 0 is 6.
No.
No, that's right.
6 times 1 is 6. What happens when you multiply a number by 0?
It turns into the same number? No, it's 0.
It's 0. Yes, it's 0. Whenever you multiply anything by 0, look into the camera, tell the people. Whenever you multiply anything
by 0, it's 0.
right. All right, so remember that. So 6 times 0 is 0, right? And now we're going to do our subtraction. So what's 1 minus 0?
1 minus 0 is 1.
Yeah, it's 1. Don't make it harder than what it is. All right. So now, what do I do with this 1? Use the arrows. Same thing I did in the last problem.
Now we got 19.
All right, now we got 19. Okay. So now, how many 6s can go into 19? 6 times what equals a number close to 19?
6 times 3.
6 times 3, and 6 times 3, what does that equal?
18.
Right. So we put a 3 up here. And then 6 times 3, you said, was 18?
Mm-hmm.
Right, 18 right here. And then we subtract. And what's 19 minus 18?
1.
Right? And now what do we do with this one?
You put it next to the 2.
So we go up here like this. And we put the 1 right there.
Now we got 12.
And now we got 12. Right? We got 12 now, right? So now we got 6. How many 6s go into 12?
2.
2. Where do I put the 2?
You will put it on top.
On top, next to the 3. And then what do I do with this 2? Do I multiply 6 by 2?
Yeah.
Yeah. And what does that equal? 6 times 2? You know what 6 times 2 is.
Wait. Oh, 12.
Right. She know what she playing. She know what 6 times 2 is. Right? 6 times 2 is 12. And then you subtract. What's 12 minus 12?
0.
12 minus 12 is 0. And now what do you do with the 0?
Put the 0 with the 7.
Slide it up there. Now 0 next to a 7,
It's still 7.
to the left of 7, that is. If the 0 is on the other side of it, that would be 70. That would be a different situation. But 0, 7 is just 7, right? So how many 6s go into 7?
How many 6s go into 7?
Yeah.
1.
1. Right. Only 1. So where do I put the 1?
Put the 1 on top.
Put the 1 on top like that. And then what do I do with this 1?
You multiply with the 6.
Multiply with the 6. 6 times 1. See, she caught on to this already. I promise you, I never showed her this before. I promise you. Right? So we got 6. And then we subtract, right?
Mm-hmm.
So now we do 7 minus 6. What does that equal?
1.
1. Now, I have no more columns over here. There are no more columns. There are no more numbers in the dividend, right? Mm-hmm. So that means that this is my remainder. That's my remainder. And my quotient is, this 0 doesn't count. That's another thing. If the 0's in front, it's basically irrelevant, right?
So there's no more.
It's just 321. So my quotient is 321, and I have a remainder of 1. Now the first answer, or the first problem, we didn't have a remainder. Our remainder was 0. The second problem, we have a remainder of 1. So that's what that looks like. And this, ladies and gentlemen, is division by the box method. All right? All right? That's it. That's it. You know? That's it. How do you feel? Feel like you learned something new?
It was fun.
It was fun, right?
It's funner than doing the addition one.
You like it better than the addition one? Okay. Yeah, see, math is fun, right? Tell the people. Math is fun if you know how to do it.
Mm-hmm. Math is fun if you know how to do it.
If you know how to do it. If you don't know how to do it, it's horrible. It's the worst. If you don't know how to do it, it's just frustrating. It makes you want to fight somebody, right? Right? But if you know how to do it, then it's cool and it's fun. It's like playing a game. It's like playing Roblox. It's not fun as Roblox?
When
Yeah?
It's like obvious and you keep on messing up on one level, you start raging because it's annoying and you just want to get back.
All right, let me cut her off because I just said like Roblox is like a buzzword for her, so she'll go on forever talking about Roblox because she loves Roblox. All right, but anyway, before we go, I do want to shout out these people on my sweatshirt. I want to shout out Nelson Mandela and Winnie Mandela. I want to shout out Osaji Fo, Kwame Nkrumah. I want to shout out Patrice Lumumba. I want to shout out Thomas Sankara. I want to shout out Bantu Steve Biko, and I also want to shout out Fela Kuti. All right, and a lot of other people that have been fighting for our liberation. And have fought in our liberation. Ancestors that are physically not longer physically here, but their legacy lives on. Anything else you want to say?
Bye.
You just want to say bye?
Yeah.
Okay, I feel you. All right. Please like the video. Please subscribe to the page if you haven't already. Tell some other people about the page. And always remember that there's all this math all around you. Peace.
Bye.
Hit it again.